Today we're going to multiply polynomials. We're going to start with basically the distributive property. When you're adding polynomials, you do not change the exponents. However, when you're multiplying, that's when you do change the exponent. So if I take 4x to the fifth times x, that's really 4 times x to the fifth times an x to the first. That becomes 4x to the sixth. So 4x to the fifth times x is 4x to the sixth. 4x to the fifth times 2, you'd multiply the 4 and the 2 and get 8x to the fifth. Example 2 starts with a negative, and there's a negative that you have to multiply it with, but try example 2 on your own. Pause the video if you're watching the video. You should have gotten negative 2x to the fourth plus 2x squared minus 14x. Please check your exponents. Also make sure that this middle term is plus 2x squared because you did negative 2x times a negative x. Okay, the next one, multiplying binomials. A lot of your teachers in the past have had you use a trick called FOIL. Do you remember the term FOIL? Have you heard that before? FOIL means first, outer, inner, last. It means multiply the first terms together, multiply the outer terms together, multiply the inner terms together, and then multiply the two last terms together. Personally, I think that FOIL is a 4-letter F word that should never be used in a math classroom, because FOIL is something that only works if you're multiplying a binomial with another binomial. So if I had something like 3x minus 1 times 2x squared plus 3x minus 2, you can't use FOIL for that. So FOIL is a trick that helps you with one specific type of problem if you remember what FOIL means and how to do it. It really makes more sense to think of this as what you're really doing in math. I don't like tricks in math. I want you to understand what you're really doing. What we're really doing is take the 3x, distribute it to x plus 2. Then you take the negative 1 and distribute that to x plus 2. You're really doing the distributive property twice. And if you think of this as multiple distribution, it makes a lot more sense than FOIL. So from this point onward, FOIL is a 4-letter F word that we're not going to use because what the FOIL, it's just a dumb trick. Okay? Okay. So we would take 3x and multiply it. We do 3x times x. That would give us 3x squared. And then 3x times 2 would be 6x. We have distributed 3x to everything in the second set of parentheses. We are done with it. Now distribute the negative 1. Negative 1 times x is negative 1x. Negative 1 times 2 is negative 2. Once you're done distributing, look at if there are any like terms that we could combine. These two middle terms are like terms, so our final answer is 3x squared plus 5x minus 2. When you square a binomial, you cannot just apply that square to everything inside. If this was 5x squared, we could do 5 squared times x squared. If it's only multiplication inside, you can apply the exponent to everything inside. But this is addition. This means x plus 5 twice. X plus 5 times x plus 5. Up here, 5x squared also means 5x twice. But when it's multiplication, that means you're multiplying the 5 twice, you're multiplying the x twice, so that works. But with addition, it doesn't work that way. You have to do that binomial times itself. So now that I have x plus 5 times x plus 5, I want you to practice double distribution, or as you've called it in the past, foil. I really don't like that word. I really, really don't. Try example 4 on your own, and then we'll talk about how this applies to example 5. Okay, when you double distribute, you should end up with x squared plus 5x plus 5x plus 25. So x squared plus 10x plus 25. Now there is something kind of unique that happens here. 10 is 5 times 2. 25 is 5 squared. Anytime you square a binomial, this pattern happens. So if I gave you x plus 8 squared, and you knew about this pattern, you could very quickly say, okay, this multiplies out to x squared plus 8 times 2 is 16, so 16x. 8 squared is 64, so plus 64. But remember how I just said a minute ago that tricks are not necessarily the best way to do math? If you remember this pattern, then yes, this helps you to get your answer a little bit faster. But I don't want to bog you down with tricks. There's this misconception in math that in order to be good at math, you must be fast at math. That is completely false. If you can write out every single step and get the correct answer every time, I don't care how long it takes you to do that, that means you're good at math. Being fast doesn't make you better at it. Okay, in example 5, we have x plus 5 to the third. That means x plus 5 times x plus 5 times x plus 5. We have 3 of them. You have to do this in 2 separate steps. So our first step would be to take 2 of them. I like to use the second 2 and multiply x plus 5 times x plus 5 first. Well, what did we just do in example 4? We just did x plus 5 times x plus 5. So this part we found out in example 4 was x squared plus 10x plus 25. We now need to multiply another x plus 5 into that. Here's where FOIL really truly does not work for you. You have to double distribute on this one. So I would start with my x. I am going to distribute my x to the second set of parentheses. X times x squared is x to the third. X times 10x is 10x squared. X times 25 is 25x. I have now finished distributing the x. Now I need to distribute the 5. 5 times x squared is 5x squared. 5 times 10x is 50x. And 5 times 25 is 125. If you wanted to, once you start distributing that second portion, if you wanted to put those here underneath so that the terms match up vertically, so it'd be easier to combine your like terms, you could. I usually forget to do that. I always write it out horizontally, but you could stack the terms that are the same underneath the previous terms if you wanted to. Anyway, once you're done multiplying it all out, now we need to combine like terms. We've got x to the third. For x squared, we've got 10x squared and 5x squared, so that would be 15x squared. For our x's, we have 25x and 50x, so 75x, and then our plus 125 at the end. On your assignment for section 5.3, we are going to skip number 60, skip number 70, and skip number 72. I believe that gets us down to 9 problems.